Hi everyone. Welcome to the flip lesson on completing the square with me, Mr. Whitehorse. As you watch this video, I encourage you to pause it as many times as you need and rewind it until you learn the content. In class, we've been solving quadratic equations, and one of the ways that we've talked about is solving by factoring. Well, in many cases, solving by factoring is not convenient or even possible. One of the ways that we can solve a quadratic equation when factoring is not possible is by using a method called completing the square. Before I show you how that works though, we have to first review what a perfect square trinomial looks like. Perfect square trinomials are in the form a squared plus 2ab plus b squared, where a and b can be any term. So two examples are below. The first one, 4x squared plus 20x plus 25, we see that the value of a is actually 2x, and you can tell that because 2x times 2x gives you 4x squared. The value of b is 5, because 5 times 5 is 25. And the 20x in the middle is the product of 2, 2x, and 5. In the one below that, a squared minus 6a plus 9, the value of a is a, the value of b is negative 3, and if you multiply 2, a, and negative 3, you get negative 6a. So, when you have a quadratic equation in which one side is a perfect square trinomial, it can easily be solved by taking the square root of each side. Watch as I do this so that you can see how it's done. Now I'm going to go up to the board, so if my voice tapers off a little bit, you'll know why. So looking at the left side, you can see that that trinomial is the same as the perfect square I just showed you on the previous page. Here's how you solve a quadratic equation by completing the square. First, you verify that the trinomial is a perfect square, and it is. So once you verify that, factor it. And we know that x squared minus 6x plus 9 can be rewritten into x minus 3 times x minus 3. We always carry down the equals 25 the whole time. But instead of writing x minus 3 times x minus 3, that's equivalent to saying x minus 3 squared equals 25. So to solve for x, I need to get rid of that squared, that exponent of 2. To do that, I can take the square root of each side. If I take the square root of the left side and the right side, that will give me x minus 3 on the left side. And on the right side, we have to consider when we take the square root of a number, the square root can either be positive or negative. So the square root of 25 is either positive 5 or negative 5. So now we have actually two equations there. We have x minus 3 equals positive 5 and x minus 3 equals negative 5. So what we do is we solve both of those equations to get our roots. First I'm going to do x minus 3 equals 5. And if I solve that for x, that gives me x equals 8. And on the right, I'm going to do x minus 3 equals negative 5. If I add 3 to both sides, I get x equals negative 2. So my roots are negative 2 and 8. That's how you solve by completing the square. But that was an easy case. You can see in that case that the left side was already a perfect square trinomial. In this next example, you'll notice that the left side is not a perfect square. So what we need to do is follow these 5 steps in order to force completing the square. The first thing we do is we make sure the value of a, the leading coefficient of x squared, is 1. In this example it is. If it isn't, divide everything by that value. Your next step is to move the constant, step 2, to the right-hand side. So again, we've taken care of step 1. Now we're going to do step 2. we have to move 4 to the right-hand side. So I can rewrite this as x squared plus 8x equals 4. So I've taken care of that. The next step is the most important step, and that's why it's in bold. The next step is to take half of b, which is the coefficient of x, take half of it, square it, and add it to both sides to maintain the balance. So what I'm going to do is I'm going to cut 8 in half and get 4. And then I'm going to square 4 to get 16. And I'm going to add 16 to both sides. So my new equation ends up being x squared plus 8x plus 16 equals 4 plus 16. And then I simplify that. So 4 plus 16 I can rewrite as 20. So I've taken care of step 3, and now I'm ready to solve by completing the square. What you now do is you factor the perfect square trinomial, and we know that x squared plus 8x plus 16 factors to x plus 4 times x plus 4. And then I rewrite that as x plus 4 squared equals 20. Now to solve for x, I take the square root of both sides, and I get x plus 4 equals the positive or negative square root of 20. 20 is not a perfect square, so I can't take its exact square root. So for now, I'm going to let you stop there. However, we should always know how to simplify radical terms so that we can write our answer in simplest form. I'll show you very quickly how we do that. To simplify the square root of 20, I break it up into the square root of 4 and the square root of 5. And that simplifies to 2 radical 5. So this whole thing becomes x plus 4 equals positive 2 radical 5 or negative 2 radical 5. Please excuse the writing in green. You know how the smartboard gets. And then to solve for x on each side, I subtract 4 from both sides. So the first equation will be x plus 4 equals 2 radical 5. I subtract 4 and get x equals 2 radical 5 minus 4. With the other one, I get x plus 4 equals negative 2 radical 5. Subtracting 4 gives me x equals negative 2 radical 5 minus 4. So my roots are 2 radical 5 minus 4 and negative 2 radical 5 minus 4. So now go back to the website and fill out the Google document to rate your understanding of this lesson. I hope after watching this you have a better understanding of how to solve a quadratic equation by completing the square.